Today we are starting on page 36, and we're starting with the concept of correlation. So correlation is a matching of rock layers or fossils exposed in one geographic location to similar layers or fossils found in other geographic locations. Even if they're very far apart or on different continents, geologists will look at fossils. If there's two or more rock formations that contain fossils that are about the same age, scientists infer that the formations are also about the same age. Not all fossils, though, are useful in determining the relative ages of rock layers. So what we're really looking at is index fossils. They existed on Earth for a short length of time. They were abundant, and they inhabited many locations. So let's look at this three-dimensional thinking. So looking at the time scales for the following fossils, which fossils could be index fossils? Let's go back to the criteria. They existed on Earth for a short length of time. They were abundant and inhabited many locations. So let's see here. So we're looking for ones that existed for a short period of time. So horseshoe crabs have existed for 450 million years. Probably not an index fossil. Coelacanths, again, 425 million years. Probably not an index fossil. What you're going to do is look at the rest of these and decide which ones could be index fossils and explain why. So we've already completed this. We did this yesterday. We'll keep going. So we're going to learn something about geologists. So you're going to read this about geologists, and then you are going to write a short blog about the Alvarez hypothesis about the extinction of the dinosaurs 66 million years ago. So you're going to have to do a little research on it. You're going to have to find things like what clues did he find in the rock record, and you're going to write a short blog on what you find. This is a minimum of 2 paragraphs with 5 sentences per paragraph. Then we're going to continue on to page 38. This is going to be assigned on the classroom. On McGraw-Hill. So, how do major geologic events help build Earth's timeline? So this is a picture here of the 1980 eruption of Mount St. Helens. Answer number 1. Here, the figure below shows a hypothetical area. Assuming the ash layers have been dated as shown, what conclusions can you draw about the ages of the layers above and below the ash layers? Answer that here. Then we'll continue on. And this is the last page we're doing today, three-dimensional thinking. So scientists hypothesize that a meteorite impact may have caused a mass extinction that occurred when the dinosaurs became extinct. Evidence for this impact is in a clay layer containing the element iridium in rocks around the world. Iridium is rare in earth rocks, but is common in meteorites. So it says nearly all fossils below the iridium layer in earth's rocks are different from those above, indicating the mass extinction occurred. So, the question would be, 1, would you expect to find dinosaur fossils in undisturbed rocks that are above the iridium layer? Explain your answer. 2, how does the structure of a distinctive layer that is used as a marker determine its function? And that is all the farther we're going to go today. As always, if you have any questions, please email me, and have a great day.